Bismillahirrahmanirrahim. Hello students, welcome to the electrical engineering channel. In this lecture, we are going to discuss the second method of interpolation, which is called Newton's method of interpolation. The difference between Newton's method of interpolation and direct method is that we have to use the Newton's polynomial instead of the conventional polynomial. So Newton's polynomial can be written as f of x is equal to b naught plus b1 x minus x naught. So this is the first order Newton's polynomial, and that's why we have used f1 of x. If we are using second order Newton's polynomial, then we can write f2 of x. So that will also be discussed later in this lecture. So this is a Newton's polynomial, and if we remember the Newton's Raphson method of solving nonlinear equations, we saw a similar equation, and this equation is actually evaluated from the Taylor series. So this is the Taylor series, and we are using first two terms of the Taylor series, and if we are using first three terms of the Taylor series, then this will become second order Newton's polynomial. So this Newton's polynomial is very much similar to the Taylor series, and from here we have to find out these two constants b naught and b1, and b naught can be evaluated by substituting x equal to x naught. So this term will be cancelled out because x minus x naught will be equal to 0, and b naught will be equal to f1 of x naught. So this is the value of the first coefficient. Similarly, the value of the second coefficient can also be determined because we have already obtained the value of b naught, so value of b1 can easily be evaluated. So f1 of x1 is equal to b naught plus b1 into x1 minus x naught. The value of b naught is equal to f1 x naught, so it will be equal to f1 x naught plus b1 into x1 minus x naught. So the value of b1 is equal to f1 x1 minus f1 x naught. So we can do rearrangement, that this term can go to the left side and it will become f1 x1 minus f1 x naught, and it will be divided and it will become divided by x1 minus x naught. So this is b naught, this is b1. Both constants have been evaluated, and we can put these two values in the original polynomial, Newton's polynomial, and f1 of x will be equal to f1 x naught plus f1 x1 minus x. So this is b1 and this is x minus x naught. So now we will solve one example to find out the value of the velocity of the rocket at t is equal to 16. Again, we have to assume t naught equal to 15, t1 equal to 20, and vt naught or vt1 are also given. So v naught is equal to vt naught, and vt naught is equal to 362.78, and b1 is equal to this expression, and we have all the values. So b1 will be equal to 30.914. So put these values in this original Newton's polynomial, first order polynomial. So Vt will be equal to V naught plus V1 into T minus T naught. We can put T equal to 16 in this equation, and T naught is equal to 15. So we will get 393.69. Similarly, we can use second order Newton's polynomial to do the interpolation, and that will be called as quadratic interpolation. So quadratic, for example, a quadratic equation is the equation in which the maximum power of x is 2, or the order of that equation is 2, and the first order polynomial has an order of 1. This is also called linear polynomial. So in quadratic interpolation, we will use second order Newton's polynomial, and second order polynomial can be written as b naught plus b1 x minus x naught plus b2 x minus x naught into x minus x1. So at x is equal to x naught, if we substitute x is equal to x naught, we will get the value of b naught. Similarly, if we substitute x is equal to x1, we will get the value of b1, and after calculating the values of b naught and b1, we can calculate the value of b2. So x equal to x naught means that b naught is equal to f2 x naught. Similarly, x is equal to x1 means f2 x1 is equal to b naught plus b1 x1 minus x naught, and f2 x1 is equal to f2 x naught plus b1 x1 minus x naught. So b1 can be evaluated as f2 x1 minus f2 x naught divided by x1 minus x naught. Now we will put x equal to x2, and it will give us the value of b2. So if we put x equal to x2 in the original second order Newton's polynomial, we will get this equation, and we can substitute the values of b naught and b1 over here. So this is b naught. Only unknown value is b2. So after rearranging this equation, the calculated value of B2 is this expression. So we can calculate all the values of these three coefficients, and then we can use again this polynomial, and we can calculate the value of the function at any point. So we will put the value of x, for example, x equal to 16. If we are solving the same previous example, then we will be having the value of the velocity at is equal to 16. So this is the final expression for f2 x2, and from here we have all the values x naught, x1, and x2, and we will put all those values in this expression, and we can calculate the final value of the function at any desired point. So that is all about our today's lecture on Newton's method of interpolation. For watching more lectures, please subscribe this channel. Until the next lecture, it's goodbye.